This is Daniel Coosbury, and I'm going to keep working with binomial random variables in this video. If you haven't seen the one on the binomial distribution, I would suggest go watch that one first, because here I'm assuming you know the formulas and what makes something binomial, and I'm going to work through just a few problems mathematically to show you how to use the distribution to find probabilities. So here's one big problem I'm going to spend the video working on. We have the Pew Research Center recently reported that approximately 30% of internet users in the United States use the image sharing website Pinterest. And we're going to take a random sample of 15 internet users, and we're going to use the binomial distribution to find the following probabilities. So I'm going to work through these one at a time, starting with the probability that exactly 4 of the people sampled use Pinterest. Now, before we get started, let's look at this idea and make sure we have a binomial distribution. So for starters, we should be able to identify what P and what N are. So we have 30% of the users in the United States use Pinterest. So I think that's going to be our P, and we'll write P as a decimal, not as a percentage. And then we're going to take a sample of 15 of them. So this is going to be our number of trials. And I guess a success would be, for each of these people, it will be, I use Pinterest. A failure will be, I don't use Pinterest. And so there's a 30% chance that they say, yes, I use Pinterest. And there's a 70% chance that you fail, you don't get one. Since this is a random sample, it's a simple random sample, then we're going to assume that these are independent trials. So when you have something random like this, it's going to give us independence, which is good. What one person says is not going to affect what another person says, which is good. So we're going to find these 4 probabilities. Let's start with the probability that exactly 4 people use Pinterest. So the probability that X is equal to 4. And we've got a formula that I'm going to jot down up here. The probability for a value of X is equal to NCX times P to the X times 1 minus P to the N minus X. And so there should be multiplication signs there and there. So I'm going to find this once using the formula, and then show you how to do it in the calculator, which I think you're going to like better. So let's start with, we need N. N is 15. I'm going to jot that down over here. And P is equal to 0.3. So we'll do 15C4, where X is 4. So this works just like the function notation. X is 4, so everywhere we see an X, we're going to put a 4. And then we'll do 0.3 to the 4th power. So that'll be that part. And then we'll do 1 minus 0.3, or 0.7, so that's that part, to the 15 minus 4 power, which is 11. I'm going to go ahead and find some of these things real quick. Well, I'll just do this in my calculator, I think. I need to shrink that just a little bit. Do it over here. So I'm going to do 15C4. Which is 1,365. So I'm going to do that times 0.3 to the 4th power times 0.7. Is it okay if I do to the 11th power? 15 minus 4 is 11. And you can see, let me make this bigger so you can see what I'm doing. So you can see in this formula, this 0.3 is the chance that we get a Pinterest user, and I'm finding the probability exactly 4 of them do. So out of 15, 0.3 of them should, 30% of them should, which means that 70% will not be on Pinterest, and that would be like the other 11 people. And this is the 15C4 is out of 15 people, all the different ways you can get a group of 4 from that 15. So if I do this, I get the number 0.2186 as my answer. So that's using this formula. Now there's another way to do this, which uses a calculator function, and I'm going to show you the calculator notation as we do this. So what I write in blue is not really technically like a good way to write math. But I'm gonna write down the calculator notation. So I'm gonna use the function binom CDF. And that is found under second vars. So hit second and click vars. Okay, let me do that again because I messed up. I'm on the home screen, hit second and then hit vars. See, it'll give you the distribution catalog. We want the binomial distribution, so there's distribution, and we're gonna scroll down until we see binom PDF. Okay, so there's binom PDF. In binom PDF, we're gonna tell it the number of trials, the success probability, and the X value. So our number of trials is 15, our success probability is 0.3, and the X value is, for this particular problem, it's exactly 4. So our X value is 4, and we're gonna paste. So if you don't have a newer TI-84 and you got this on the home screen, this is how you should type on the home screen. Type your N first, comma, your P second, comma, your specific X value before third. So 15, comma, 0.3, comma, 4, hit enter, you'll get the exact same answer. So I'll just jot this down for the purpose of having notes. So this is 15, comma, 0.3, comma, 4, which, just to make a point, this is your N, this is your P, and this is your X for that problem. So this is how the notation, or this is how you should do, this is P, I'm sorry, man. This just in, my phone just told me there's a tornado watch, so I'm a little bit distracted. Not a tornado yet. So this is binom PDF. This is the one we use. So I'm sorry if you type the wrong one, it's the PDF one. And the numbers you put in, binom PDF, are N, comma, P, comma, X, in that order. If you switch the order up, it'll give you an error or it'll give you a wrong number. So this is how you find this problem. Now, the other 3 probabilities we do are pretty complicated, and frankly, I want to use my calculator to find these. So you could do these using the formula, but I want to use my calculator to find these. So I'm going to find the probability that fewer than 3 people use Pinterest. So the probability that X is less than 3, which is equal to, well, I'm going to do it like this. So there's another function in the calculator called the binom CDF, and that's the one we're going to use for this idea of being fewer than something. So the binom PDF was the one we used for X is equal to something. The binom CDF will give us, I think, less than or equal to. So not a strict less than, but this will give us a less than or equal to. So let me show you kind of what I'm going to do in my calculator. I'm going to write this event, X is less than 3, using a less than or equal to sign. So it can't equal 3. It's got to be 2 or 1 or 0. I'm going to write it using a less than or equal to sign. And I want you to believe that this event is the exact same thing as this event. Okay, so X being strictly less than 3 is the same thing as being less than or equal to 2. Now, why did I do that? Because this function needs a less than or equal to sign in order to use it. Like the binom PDF, it just needed an equal to sign in order to use it. CDF will give you less than or equal to, which is really handy because this way we don't have to find the probability that it's 0 people and then 1 people and then 2 people. We can just use this one function to do it. So I'm going to do binom CDF. And I think you do the same order. I think you do N, comma, X, comma, I'm sorry, N, comma, P, comma, X, which means I'm going to do 15, comma, 0.3, comma, in this case it's going to be 2. And when I write 2 there, when I type it in my calculator, it's going to assume I mean less than or equal to 2. So I can't put 3 in there because it would think less than or equal to 3, and there's no equal sign. So I've got to use this one. It's just the way the calculator works, and it's going to work out well. So let's do it. I'm going to go to second vars and go down to binom CDF, which is right here. I'm going to do 15.3, just like last time, and my new X value is going to be 2. That's going to be less than or equal to 2, and I get this value, 0.1268. 0.1268. And this is going to be the probability that I get fewer than 3 people using Pinterest. out of the 15. So, and this is believable because my proportion of people that should use Pinterest is 30%, and 30% of 15 is much bigger than 2. So it's like 4. It's closer to 4. So there's a 12.68% chance I get 2 or less people using Pinterest in my sample. Let's keep going. Find the probability that 1 or more people use Pinterest. Okay, so I've got 2 calculator functions that'll help me do this. 1 or more. So I've got binom PDF that I can use if I have an equal sign, and I've got binom CDF, which I can use if I have a less than or equal to sign. So I want to find out the probability that X is equal to, that 1 or more people use Pinterest, which means X is 1 or more. So we can say it's greater than or equal to 1. Okay, so right now I've got 2 calculator functions I can use. One of them if I have a less than or equal to sign, one of them if I have an equal to sign. I don't have either of these, which means I've got to do some finagling to this to get a less than or equal to sign. So I'm going to do something nice. I'm going to be really clever and say, okay, if 1 or more people use Pinterest, in fact, why don't we think of this as, can I use the phrase at least 1? Is that the same thing as 1 or more, at least 1? I think it is. I think those are the same thing. So this means at least 1, which as you guessed, I'm going to do the at least 1 trick because it's going to be easier. The probability that at least 1 people use Pinterest is going to be equal to the probability, 1 minus the probability that nobody uses Pinterest, which is X equals 0. Okay, so the chance that I have at least 1 people is going to be equal to 1 minus the probability that I have no people use it. This is going to be easy to find. This is going to be hard to find. So let's do the 1 minus the complement trick. The complement of at least 1 is none. So let's do it. So using bad calculator notation, this is 1 minus binom. I got an equal to sign, so I'm going to use the PDF one. Binom PDF, n is 15, p is 0.3, and then my x now is 0. And I can put 0 in there because that just means 0 people are using Pinterest, which is possible. It's a real thing that could happen. Oops. So I'm going to do binom. Well, let's do 1 minus binom CDF in the calculator. I gotta go find binom. PDF. So I'm gonna do 15 comma 0.3 comma 0 and paste. So that should have 1 minus binom PDF on here, and I get 0.9953 if you round to 4 decimals. So this is 0.9953. Which this is really believable. So out of 15 people, the chance that at least 1 use Pinterest is 99.5%, which is incredibly likely. So if on average like 30% of your people use it, then your chance of at least 1 people using it out of 15 is very, very high. And notice I used the 1 minus the complement trick, which was really nice on this one. What you could have done if you didn't do the complement trick, you could have found the probability that you have 1 person plus the probability you have 2 people plus the probability you have 3 all the way up to 15 and done that, frankly, 15 times and added them all together. You would have gotten the same answer. My way was not only faster, it was more efficient, and I'm less likely to mess up if I do the 1 minus the complement trick. So remember, I've got only 2 calculator functions I can use. I don't have a greater than function or a greater than or equal to function. I only have these 2. And I'm going to tell you that you can use both of these to do any problem. Like if you have both of these, you can do any sort of problem using binomial. So let's do one more, and I'm going to have to convince you that this is true. So find the probability that the number of people who use Pinterest is between 1 and 4 inclusive, meaning I can be 1 or 4 or anything in between. So this is the probability that x is greater than or equal to 1 and less than or equal to 4, which is kind of nice. And I can think of a couple ways to do this. So I'm going to show you the long way to do it, and I'm going to tell you that this is a perfectly fine way to do it. So this is equal to the probability that x is 1 plus the probability that x is 2 plus the probability that x is 3 plus the probability that x is 4. And you can find all 4 of those using binom PDF in the calculator, which you use the equal sign for. This is worth writing a few times until you remember which one's which. I'm just jotting it down over and over again so that we can remember. So you use binom PDF 4 times, add them together, and you'll get your answer. I'm not going to do it that way because that's the long way, but if you don't like my second way, do it this way because this is a perfectly fine way to do it. Okay, I'm going to try to break this into just 2 things and use the CDF thing. So I'll show you what I mean. I'm going to first write the probability that x is less than or equal to 4. Okay, so I'm going to say this is equal to that, except it's not perfectly equal. I'm going to have to take something away. This means x could be 1, it could be 2, it could be 3, or it could be 4. This is saying x could be 1, 2, 3, 4, or 0. X equals 0 is also in here. If you put in there, it's like x less than 4. X could be 0, it could be 1, 2, 3, or 4. So I don't want to count x equals 0, but when I do this, I will. So I'm going to subtract off x equals 0 and just do 2 things rather than doing 4 things. Like I said, if you don't like this trick, do it the long way, and it's perfectly fine. You'll get the answer. But what I did was I changed this into x is less than or equal to 4, which would be all 4 of these numbers plus 0, which I don't need, so I'm taking that away. I'm only doing this in two calculations instead of 4. I like doing less calculations because the less calculations you do, the less likely you're going to mess up, the less round-off error you're going to have. So this is binom CDF 15.34. There's a comma. And this is binom PDF, there's the P, 15.30. And did we do this already? I think we did. Did we do less than 4? Oh, we did less than 3. Okay, so I'll have to find this one. Binom CDF 15.3, 4. I'm sorry, that's second bars. Binom CDF 15.3, 4. And this is 0.515. You can round that up to 5. And then we just found this one, I think. I think we found it over here. We didn't write it down. We'll have to find it again. Okay, so that's one of them. The other ones is binom PDF. Make sure we pick the right one. 15.3, 0, and that's 0.0047. 0047. Okay, so see what I've done? I found the chance we're less than or equal to 4 minus the chance that we're 0. So that'll give me the chance that we're between 1 and 4, including 1 and 4. So this is 0.5155 minus 0.0047, which is 5108, which is the same number you would get if you did it the long way. You can go ahead and check my work on that. Do it the long way. Add those 4 numbers together. Do the PDF 4 times, 1, 2, 3, 4. Or you can shorten it and only do 2 calculations, which I like. Either one of these is fine. So you can do it the long way, which may make more sense to you and you may like better. And I'm saying if you like it better and it makes more sense to you, do it this way. I think this way is a little bit cleaner because you're only rounding twice rather than rounding 4 times. There's a chance, every time you do stuff like this, there's a chance you type something in wrong, you move a decimal. Here you only have 2 chances of messing up. Here you have 4 chances of messing up. So all that is to say, you can do this one either way. But the point is, once you know that something's binomial, and once you know that means you'll have n and p, you can use either of these functions because you're going to put n and p, and then whatever your x is, you're going to put n and p in the PDF function too. Once you know something's binomial, you have the n, you have the p, you can find you can find any probability you want using these 2 functions and only these 2 functions. That's why there's only 2 in the calculator, because you only really need 2. So that's kind of the takeaway from this video is You can do any binomial probability problem once you identify what n and p are by using these two functions. So your job is to keep them straight, and you might need to do some manipulating, like in problems like this. You might need to do the complement trick if you have an at least one problem. If you have a greater than or equal to problem, you're going to have to change it to a less than or equal to problem or equal to using the complement trick. So that's going to come up. And then if you have a strictly less than, you got to change it to a less than or equal to by doing that, which I hope is fine. So like I said, with any of these problems, you can use either one or both of these to solve any binomial problem. You can take my word on that one.